All right, so we're going to start with question number 3. And if you remember, this was the one that we had to make a correction to yesterday. If you did not make that correction, you want to get rid of the C that's down here. And this line right here is what should be C. So that's the first thing you want to do, is make sure that you have the lines listed correctly or named correctly. And then it says that the measure of angle number 2 is 8x minus 14 degrees. So this angle right here is 8x minus 14 degrees. Angle 6 is 2x plus 28 degrees. Angle 6 is right here, 2x plus 28 degrees. And then angle 3 is 3y minus 33 degrees. So this angle right here, 3y minus 33 degrees. It said find x and y so that B is parallel to C. So these two lines are going to come out to be parallel to each other. So all the things that we've learned about our special angle pairs and parallel lines is going to be true here. What kind of angles are 2 and 6? What kind of angles are 2 and 6? I'm sorry, I didn't hear. Yes, they are exterior angles. Same side or opposite sides of their transversal? Opposite. So they're not just exterior angles, they are alternate exterior angles, yes. They're alternate exterior angles, which means they have what relationship to each other? Are they congruent or supplementary? They are congruent. So angle 2 is congruent to angle 6. That means the measurement of angle 2 is equal to the measurement of angle 6. So we would have 8x minus 14 equal to 2x plus 28. We want to get our x's to the same side now. How do I get my x's to the same side? Subtract 2x from both sides. So that would give me 6x minus 14 equals 28. Then I'm going to add 14 to both sides. I get 6x equals 42. And then I divide both sides by 6, and we get that x is how big? X is 7. So there's one of the things they asked me to find. We still need to go through now and find y. Well, what do you notice about angles 2 and 3? They're adjacent, and together they form a straight line. So what do we call that pair? They're a linear pair, yes. Angle 2 and angle 3 form a linear pair. So that means they will add to 180. So the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Angle 2 is 8x minus 14. Drop down my plus sign. Angle 3 is 3y minus 33. Bring down my equals 180. I have a problem though, because I have an x and I have a y.
You plug in what you already have.
Yes, we're going to plug in what we already found for x. So I have 8 times 7 minus 14 plus 3y minus 33 equals 180. What is 8 times 7? 56 minus 14 plus 3y minus 33 equals 180. And now I need to combine my constants, the things that don't have variables. So 56 minus 14 minus 33. What do I get when I combine all of those together? 9. 3y plus 9 equals 180. Then we subtract 9 from both sides. What is 180 minus 9? 171. So 3y is equal to 171. We divide both sides by 3. And y is, I'm sorry, how much? 57. So 7 for x and 57 for y. What else would you guys like to see off the review? Number 5? Absolutely. Number 5, we have a proof. We start off in this proof by knowing that these two angles, angle 1 and angle 8, are congruent. And the reason we can say that, the reason that we know that is because it's given. So this angle right here is congruent to this angle right here. I do not know the lines are parallel. That's the thing that I am trying to show would have to be true in the end. Line J parallel to line K. I don't know that the lines are parallel. The only thing I start off by knowing is that angles 1 and 8 are the same size. Do I know anything else that's either the same size as angle 1 or the same size as angle 8? Angle 4 is the same size as angle 1. So I can say that over here. Angle 4 is the same size as angle 1. Why can I say that? Vertical angle theorem. Those are vertical angles. Okay, so I know that 1 and 4 are the same size. I know that 1 and 8 are the same size. So 1 and 8 are the same size. 4 and 1 are the same size. So what else do I know? Which other two angles would have to be the same size as each other? 4 and 8, yes. Angle 4 has to be the same size as angle 8 because they're both the same size as angle 1. Angle 1 is the same size as angle 8. Angle 1 is the same size as angle 4, so angles 4 and 8 have to be the same size. I've got two possible reasons that I could use to be able to say this. Substitution and transitive. To be really technical, this is the transitive property. But I would not take off points if you said it was substitution. Because I know that angles 4 and 8 are the same size now by the transitive property, these two angles are corresponding angles. And since I just figured out that they're congruent, that means the lines have to be parallel. That's what my corresponding angles theorem converse tells me. If corresponding angles are congruent, that means the lines are parallel. What else would you guys like to see? Question number 10, absolutely. Yes. Question number 10, given the points -3, -14, and 5, -2, find the slope of the line parallel and perpendicular that goes through the given points. So we want the line that is parallel. That means it has to have the same slope. And we want the line that is perpendicular. That means we need a line that has the opposite sign and and reciprocal. So we're going to flip our fraction. So the first thing I need to do is find the slope through these points. Slope is y2 minus y1 over x2 minus x1. You will get that formula on the test. In an ordered pair, we have x's and y's. So I pick one of my points to be x1, y1, and then the other point would be my x2, y2. So in my numerator, I want just the y's. So my numerator uses these two numbers right here. So I would have -2 minus -14. In my denominator, we're going to use the x's, so these two numbers. So I would have 5 minus -3. On both of these, top and bottom, we are subtracting a negative number. So I really have -2 plus 14 up here and 5 plus 3 down here. What is -2 plus 14? 12. And 5 plus 3? 8. So there's my slope, but it's not in simplest terms. It is not in fully reduced form. There's something that will go into both the 12 and the 8. What's the biggest thing that goes into both the 12 and the 8? 4 goes into both. So we can divide top and bottom by 4. What is 12 divided by 4? 3. 8 divided by 4? 2. So here's my slope. Same slope for parallel. So for my parallel line, the slope is 3 over 2. Is that slope, the one that I just wrote down, a positive or a negative number? Positive. So the perpendicular slope would have to be negative. And then I flip the fraction over, so instead of 3 on top and 2 on the bottom, 2 on top and 3 on the bottom. What else would you guys like to see? You said 11? Oh, 12. Yes, absolutely. Number 12. So we have to use what we just talked about with slopes here. For a parallel line, we have the same slope. For a perpendicular line, we have opposite sign and reciprocal slope. If it's anything else, then it's not parallel or perpendicular. So they gave me a line to look at. They gave me this line right here. Which piece of that line is the slope? 1/8. So looking at these other lines, the only part I care about is the M. This number right here. I don't care about the y-intercepts on any of them. Which one of those has the exact same slope as my given line? C. So C would be the one that is parallel. For perpendicular, my 1/8 is a positive, so I know it needs to be a negative, and then I'm going to take that fraction 1/8 and flip it over to 8/1. But what is 8 divided by 1? Yes, -8/1 is just -8. Which one of the two remaining lines has this as the slope? B. So B would be perpendicular. Part A is the reciprocal, but it's not the opposite sign. It has to be both the reciprocal and the opposite sign to be perpendicular. So A would be neither. If it only has one piece for perpendicular, it is not perpendicular. It has to have both of those features, opposite sign and flipped fraction. What else would you guys like to see?
Number 11.
Number 11 while we're here? Sounds good. So yesterday on the skills check, there were a lot of people that graphed me the given line, and that was it. That is not what I'm looking for on this problem. If you graph the given line, I won't take off points, but it won't give you points either. That's not the piece that I'm looking for on this problem. We want to graph the line that is parallel in part A. So I'm going to need the same slope. And I want it to go through this point right here. So this you have to graph first. If you don't put that point down on the graph, it is automatically wrong. Please remember when you're looking at an ordered pair like that, the first number is the x. That's telling you how far left or right to go from the origin. So from the origin, from the center, from 0, 0, we're going to go left 4. And then the second number is our up-down number. We're going to go up 2. So here's a point that I have to have on my line. And now I need to use the slope. What is the slope on the given line? Yep, 1/3. Yep, there's our slope. This parallel line is going to have the same slope, so it's a slope of 1/3. That numerator is my rise, and the denominator is the run. Since the rise is positive, that's how much we're going to go up. If the rise was negative, we would go down. Since the run is positive, we're going to go to the right. If the run was negative, we would go to the left. So from that yellow point that I put down, we are going to go up 1 and right 3. Put a point down. And then we're going to do it again. Up 1 and right 3. Up 1 and right 3. Up 1 and right 3. And I can make it go backwards, so do everything in reverse. Down 1 and left 3. And then we grab our straight edge and we trace through those points. There's my parallel line. Nope. You're not graphing that line at all. The only thing that you need that given line for is the slope. All right, and then we get to part B, where we're going to do the perpendicular line. This has opposite sign. And reciprocal slope. So we're going to flip that fraction over. But the first thing we do is graph this point. So 1,6 means go to the right 1 and then up 6. So here's our initial point. My perpendicular slope, I have to look at my original slope, which was 1/3. That's a positive. So my perpendicular slope will be a negative. And then I take the fraction and I flip it over. Instead of 1 on top and 3 on bottom, it's 3 on top and 1 on bottom. When I'm doing rise over run, I have one negative sign. That one negative sign either goes with the top or it goes with the bottom, but not both, because you only have the one. I'm going to put the negative sign with my numerator. So that makes -3 my rise, which means I'm actually going to be going down. But then my run, my 1 down here is still a positive, so I'm going to run to the right. So we go down 3 and right 1 and put down a point. Down 3 and right 1, down 3 and right 1, down 3 and right 1. I can't go any further down because I can't go down 3 without running off my graph. And I can't go backwards. I can't do everything in reverse because if I go up 3 from that first point, it puts me off my graph. So then you grab a straight edge and you go through those points that you have just plotted. That is the perpendicular line. You do not have to graph the given line. Again, if you do graph the given line on there, that's fine. I won't take off any points for it. It's not wrong. But it's not the thing that I'll be grading and looking at. That given line is only there so that you know what the slope is. Yes?
It's kind of hard to graph the line. Like, it's kind of hard to graph the perpendicular line because we don't have a straight edge. So.
You will have a straight edge on the test. Okay. And you're welcome to use the side of your book or the edge of the calculator or something as your straight edge right now. That perpendicular line and the parallel line should be making a right angle with each other. What else would you guys like to see from the test review? You said 14? Absolutely, I can do 14. Name the following pairs of angles, if possible, and describe their relationship, congruent or supplementary. So the first two angles we have are 10 and 11. What line do they both touch? They both touch M. So M is our transversal. They don't touch this line at all, so I don't need to look at that even one little bit. Are those interior angles or exterior angles? Interior. Same side or opposite sides of M? Same side. What do we call same side interior angles? Consecutive. That's okay. Corresponding is our matching corners. These are consecutive. Consecutive means one right after the other. So as I look across line M, 10 and 11 are like side by side right there. These are consecutive interior angles. Are consecutive interior angles congruent or supplementary when the lines are parallel? Supplementary. When the lines are parallel, these angles are supplementary. Do I know that the lines are parallel here?
Oh, yeah.
Yes, we've got those arrows on the line, so they are parallel. So that's why we can say that they are supplementary.
I thought you talked about lines L and M. It's kind of confusing because there's two separate parallel lines.
Yep, there is. L and M are parallel because they also have the arrows on them. And S and T are parallel because they have the arrows on them.
So are you referring to a specific pair?
Yes, I was, because I had line L blocked out. So we were only looking at S and T. Yep. All right, angle 6 and 14. 6 is right here. 14 is right here. What line do they both touch? They both touch S. We don't need to see T at all. S is our transversal. Are these both interior angles? No. 6 is interior, but 14 is exterior. What do I look for if I have one interior and one exterior angle? Matching corners. I look for my correspondings. What corner is angle 6 in? Bottom right. What about here? Bottom right. Since they are in matching corners, what do we call them? Corresponding angles, yes. Are corresponding angles congruent or supplementary? Congruent. Most of the angle pairs that we've learned about are congruent. There's only 3 that we've learned about that are supplementary. One of the ones that we've learned about that's supplementary is linear pairs. And then both of the consecutives, consecutive interior, consecutive exterior, are supplementary. All right, angle 16, this one here, and angle 3, this one here. What line do they both touch? They both touch T, so we don't need to look at S at all. I want to keep all of the lines that my angles are touching. They touch L, M, and they both touch T. Are those both interior angles? Are they both exterior? Yes. Same side or opposite sides of their transversal T? Opposite. So we call them alternate exterior angles. Congruent or supplementary? Congruent. (15) and 11. Here's 15, here's 11. What line do they both touch? They both touch M. So that means I don't need to look at L. Nope, because they don't touch L.
Oh, yeah, okay, that makes sense.
Is there any other lines that they have in common? T. So I don't even need to look at S. They don't just have one line in common, they have 2 lines in common. Yep, that means it's either linear pair or vertical. If they have 2 lines that they both touch, it's either a linear pair or vertical angles. In this case, because they're adjacent, they are a linear pair. Yes.
How do we scratch off the lines that the angles aren't touching? If that makes sense, because you
Like if there's too much to look at on the page?
Yeah, because I notice how you've been scratching off. Like for example, you scratched off lines L, S, and T.
No, I left T. Just L and S. Yep.
Lines L and S. So I wonder if we could do that during the test, but that would probably be a lot of writing and erasing. So
You don't have to do that. I do that so that we can see this easier.
alright.
When it comes to the test, if you can see these angle relationships without marking out lines, go for it. Or if it helps you to block things out, I can give you Post-it notes to cover up the ones that we would be scratching out.
Oh yeah, that really helps.
Yep, you guys can have Post-its if you would like them. Just let me know tomorrow when we're doing or when we start the test. If you would like some Post-it notes, I will happily bring them to your desk.
Okay, yeah.
All right. Are linear pair angles congruent or supplementary? Supplementary. Those are supplementary. All right, then we have 3 and 16. Didn't we do 3 and 16 already?
Yeah.
Yeah. 16, 16, 3, 3. They just switched the order. Made it look like a different problem because they switched it around. But it is the exact same angle pair, so those are also alternate exterior angles. Then we have 6 and 9. Here's 6. Here's 9. What line do they both touch? They both touch S, so I don't need to look at T at all. I can block that one out. I can cover it up with my Post-it. Are these interior or exterior angles? Interior. Same sides or opposite sides of S? Opposite. So these are alternate interior angles. Are alternate interior angles congruent or supplementary? Congruent. And then we have our last one. We have angle 4 right here and angle 7 right here. What line do they both touch? They both touch T, so I don't need S. Do they have anything else in common? L, so I don't need to look at line M either. Since I was able to block out 2 lines, they touch the same 2 lines. It's either a linear pair or vertical angles. These are vertical angles. If they do not have 2 lines in common, they can't be vertical. Are these congruent or supplementary? Congruent. All right. We've got 10 more minutes. That's enough time for between 1 and 3 more questions, depending on the length of the question. If it's a really long one, I'll only have time for 1. If it's short ones, I'll have time for 3. Yes. You said 19? 13. Thank you. Number 13. Write 2 equations in slope-intercept form for the lines that are parallel and perpendicular to y equals 4/3 x minus 2. So parallel, we need the same slope. For perpendicular, we need opposite sign. And reciprocal slope. So we're going to flip our fraction. So I'm going to divide my paper in half. On one side, I'm going to do parallel, and on the other side, I'm going to do perpendicular. They gave me a line, and they gave me a point. The line that they gave me, this one right here, what's the only part of it that I care about? The slope. I don't care about that y-intercept at all. I only need the slope. My parallel slope is going to be exactly the same, 4/3. My perpendicular slope, I need the opposite sign, so it's going to be a negative, because 4/3 is a positive. And then I have to take the fraction and flip it over. Instead of 4 on top and 3 on bottom, we have 3 on top and 4 on bottom. And then we need to use point slope form for a line. Y minus y1 equals m times x minus x1. You guys will have that equation to use on the test. And we are told that it passes through this point here, negative 2410. So that's my x1, y1. So we're going to substitute in now y minus, what is my y1? 10. So I put 10 in here for y1. Equals, what's the slope that we want? 4 over 3. And then parentheses, x minus, what's my x1? Negative 24. So he goes inside a special set of parentheses here because we are subtracting a negative. That's going to turn into a plus now. So y minus 10 equals 4 over 3 times x plus 24. We take 4 over 3 and it gets distributed to both of the numbers inside, not just to the x. Y minus 10 equals, we do get 4/3 x, but then we have to remember to distribute to the 24. 4 over 3 times 24. Does anybody know what that comes out to be? 32. Then we have to add the 10 to both sides. And so my parallel line equation would be y equals 4 over 3x plus 42. For perpendicular, this looks almost identical. My setup is still y minus 10 equals, I'm going to leave space for the slope, and I have x minus negative 24. In that space where I left room, that's where we put our perpendicular slope. One of the things that I noticed yesterday when I was grading the skills check is that a lot of people were using the right formula. We were taking our point, our x1, y1, plugging it in the right spots, but then we were using the same slope when we wanted the perpendicular line. You can't wait until the end to switch it to the perpendicular slope. You have to put the slope that you want in right from the beginning. So then I take that negative 3/4, I distribute that to both of these pieces. This right here is going to turn to a plus. So then I would have y minus 10 is equal to negative 3 over 4x. This is going to be a positive 24, but I'm multiplying it by a negative 3 over 4. So this is going to be a minus here. What is 3 over 4 times 24? 18. So I have a minus 18. We add 10 to both sides. And my final answer for perpendicular, y equals negative 3 over 4x minus 8. We only have 3 minutes left, which is unfortunately not enough time for me to go over any other problems, but I do want to show you on Canvas where we already have some things posted. All right, so on Canvas, if you go to our Canvas homepage, from the main homepage, you need to click on Modules. Once you are in Modules, you want to go find Module 3B. You're going to scroll almost all the way to the bottom of 3B until you see today's date, Tuesday, 10/1, review for Module 3B, Test Day 2. Click on that. That takes you here. As you scroll down, the videos for each class period today will be populated in here as soon as they are finished being recorded. So those will go up throughout the day. And at the very, very, very bottom of the page is the test review answer key, where I have all of my worked out solutions for every single problem there. So you guys can get in and check your work. I will be collecting the test review for a completion grade tomorrow. You need to get that finished up and turned in. Also, tomorrow I will be giving you a worksheet that you will use for your virtual day assignment on Thursday. I do not see you in person on Thursday, and we do not have a Zoom on Thursday. You guys will have a relatively short video to watch, and there's a worksheet that goes along with it so that you don't have to draw the pictures on your own. You need to follow along with the video, and then I will clarify on Friday.